Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Well, today we want to continue our lecture for the topic of arc length. Welcome to our video about mathematics, especially the lecture of calculus. Today we want to talk about arc length. There are three cases: the arc length in Cartesian coordinate, the arc length in parametric equation, and the arc length in polar coordinate. First of all, we would like to concentrate on the arc length in Cartesian coordinate. So our topic is about the arc length in Cartesian coordinate. As a motivation of our lecture, the arc length is motivated by the following fact. For instance, if we have a square like this, we have a circumference is 2 times p plus 1. Here we have triangle. The circumference is a plus b plus c, and the distance between 2 points x1 y1 and x2 y2 is equal to the square of the different square and the difference square. So altogether the r is actually the distance between this point and that point. What about the situation like this? If we have r, namely k, that is the x comma y, where the x is between a and b and the y is equal to fx, then the k is like this. The question is, what is the length of the arc k? In this section, we would like to find the formula of the arc length k by using definite integral. How to find that? How to find the formula? Because we want to use the definite integral, then we make a partition. For instance, the k is given by this set between a and b. We have to make a partition, the p, x0, x1, x2 until xn, where the x0 is equal to a and xn is equal to b. By using this partition, we will have a point t0, t1, t2, tn, where t0 is equal to a, ha, ti is equal to xi, a from 1 until n. Yeah, and the tn, of course, the b, h, like this. So if we have the partition here in the interval ap, then we have the t0, t1, t2, ti minus 1, ti, tin minus 1, tn. And then we want to find the formula of the length of the arc k. How can we find that? We have to approach. The blue one is approached by the red one. The blue one is approached by the red one, and so on. So in every pieces here, we approach the curve by using the straight line. For doing this, we have to remember our calculus 1 about the mean value theorem. It just says that if we have a curve like this. The peak A is a point AFA, the P is P point FP. Then there exists a C here such that F prime C is equal to the ratio between FP, FA divided by P minus A. That means there exists a point C such that the gradient of the slope, the red one, the gradient is equal to the gradient of the line AB. We want to use this to prove our formula. So after we have the partition, then we have the straight line T0, T1, T1, T2, and so on until Tn minus 1, Tn. And the straight line have the distance. The distance is actually the root of the xi minus 1 square plus hxi minus hxi square. And then we sum up from 1 until n. But then from the interval xi minus 1 and xi, we use the main value theorem. That is said that there exists Ti in the interval xi minus 1 xi such that the hxi minus xi minus 1 is equal to the derivative the x prime Ti time delta xi. And then we replace this by using the right side of this equation from mean value theorem in calculus 1. So we replace this expression by using this expression. So the sum will become the following. So the sum will become the sigma of the root square of xi minus 1 square plus the h prime, this is the derivative of the h in Ti square time delta xi square. Because this is the square, we take it out, equal to delta xi. Delta xi square, take it out from the square, become delta xi. So we have this expression as the SPF, the sum of the partition with respect to, the sum of the SPF, with respect to the partition P and the function H. From the definition of the definite integral, if we take the norm P tend to 0, where the norm P is actually the maximum of delta xi from I equal to 1 to n, and then we take this one, it becomes the integral, the sigma becoming integral. So that the arc length is equal to integral AP root square of 1 plus, this is actually h prime become dy dx square dx. So this is the formula of the arc length for the Cartesian coordinate. Once again, if we have the function y is a function of x, then the formula of the arc length is equal to this formula. So we already found this formula. If we want to calculate the function h, or the function x is equal to the gy, the y from c until t, then the s become like this. It's just the integral with respect to variable y. You can find in many books the same description. For instance, the book of Sullivan and Miranda, they describe in the same way as our discussion earlier, something like that. They also have the same formula. The formula is like this. The formula is the same. that the arc length is equal to the integral AB, the square root of the 1 plus f prime x squared dx. For example, if we want to find the arc length of the curve fx is equal to length sec x between 0 and pi divided by 4, the curve look like this from 0 until pi divided by 4, then we can use that formula. First, of course, we have to look for the derivative of the length sec x, that is f prime x is equal to the secant x tangent x divided by secant x, that is equal to tangent x. Because the f prime x is equal to tangent x is continuous on open interval minus phi divided by 2, phi divided by 2, which contain from 0 until phi divided by 4, because phi divided by 4 is less than phi divided by 2. Then we can use that formula, that is the s is equal to the integral from 0 until phi divided by 4 of the root square of the 1 plus f prime x squared dx. So this is equal to the integral from 0 until phi divided by 4 of the root square of the 1 plus tangent square x dx. This is equal to secant square x. So the root is equal to secant x, where the antiderivative of the secant x is ln secant x plus tangent x. If we took the 0 to x and phi divided by 4 to x, then we have this number. So the arc length of this curve is actually equal to the length of the absolute value of the square 2 plus 1. That is the first example. The second example, if we have the fx is equal to x power 2 divided by 3 from 1 until 8, we have the following graph. If we want to make the graph from minus 4 until 8, the graph is just like that. But we concentrate only from 1 until 8. From 1 is 0, 1, 2 until 8. By using that formula, we have that the s, the arc length is equal to the integral from 0 until 8, from 1 until 8, this is from 0, 1, from 1 until 8, of the square root square of 1 plus f prime x squared dx. It is very easy to find that because the prime x, the f prime x is actually from this one, we have 2 divided by 3 x power 1 over 3, this one, but we take this square. By using very simple calculation, we have this integral. I don't want to go in detail. Yes. By using a definite integral, we have that one. And finally, we have 1 over 27 times 80 square 10 minus 13 square 13. This number is not good number, but anyway, this is good example because this is a rational function. We can also have some other example from the book of Rode. For instance, this one. We want to find the length of the circle. This is the circle with radius r and the center is 0.0. Because this circle is symmetric with respect to the y-axis, so that we can count only in the in the first quadrant. You can only count in the first quadrant, and then the result multiply by 1, 2, 3, 4 by 4 quadrant. So explicitly we have to write x squared plus y squared is equal to r squared in Cartesian coordinate. Well, by using the implicit formula, we have that the derivative of the circle is 2x plus 2y dy dx is equal to 0. So the dy dx is equal to, it moves to the right side, so this is the minus x divided by y. So this is the derivative of the circle, because the circle is implicit function in Cartesian coordinate, so that we can make it quadrat and then take it on the formula. The formula is that the s is equal to integral ab square root square of 1 plus dy dx square dx. The dy dx is equal to minus x divided by y. If we take this is the quadrat power of 2, then we have this one. Okay, so because the r square plus y square is equal to r square, we can replace this one by r square. So this is r square divided by y square. So altogether, if we take the root, then we have the integral from 0 till r of r divided by y. Why from 0 to r? Because we move from AB in Cartesian coordinate with respect to r, the polar coordinate, because the polar coordinate is equal to r square is equal to x square plus y square. So altogether in polar coordinate we have the integral of r divided by y from 0 until r. The y itself is equal to r square minus x square. And by using the formula of the definite integral, we have that this equal to the arc sin x per r, or sin minus 1 x per r from 0 until r. So altogether, if you calculate, it is r divided by 2. But this arc length is only on the first quadrant, so we have to multiply by 4. So the circumference of the circle is 4 times phi r divided by 2 equal to 2 phi r. As we know that the circumference of the circle with radius r is equal to 2 phi r. This is the proof by using the next example. For instance, if we have the parabola x square is equal to 4y from the vertex to the point where the x is equal to 2, what is the arc length? How much is the arc length? As usual, if the x square is equal to 4y, then the y is equal to x square divided by 4. Then the dy dx is equal to 2x divided by 4 equal to x divided by 2. The graph is look like this. And then we use this formula that the s is equal to the integral of 0 until 2, from 0 until 2, the integral from 0 until 2 of 1 plus dy dx square. Dy dx is equal to x square divided by 2. So altogether we have 1 over 2 integral 0 until 2 of the square of the x square, the square root of the x square plus 4 dx. By using the definite integral, we have that this is equal to 1 over 2x and so on. So we can use the a is equal to 2 here. So 1 over 2 x, the square of x squared plus a squared, where the a is equal to 2. So this is in chapter 4, actually this is calculus 1. So what is the s in the next page? So the s is equal to the 1 over 2 integral from 0 until 2x. This the a is equal to 2. So 1 over 2, 2 square 2 and so on. When we calculate in detail, I don't want to calculate in detail because of the time. We have that approximately it is equal to square 2 plus log of the 1 plus square 2. It is nearly approximation 2.295. That is the length. 2.295 is the length of this arc. What about the length with respect to y-axis? I don't want to prove it, but it is very easy to prove by the same way that the partition with respect to the y-axis from C until D, and then finally we have that the s is equal to the integral from CD of the root square of 1 plus g prime y square dy. For example, or this is the example. For instance, we want to find the fx is equal to x power 2 divided by 3 from minus 1 until 8. The solution is that the f prime x is just the derivative of this, just equal to 2 divided by 3 times x power 1 over 3. And this does not exist at x is equal to 0 because the curve like this, so there is no derivative in 0 here. Okay, so because we want to take from minus 1 until 8 through 0, we have to divide it into things. The right side we call it the g2y. The right side from minus 1 to 0 we want to call it g1g, g1y. This is the g1. Why we have to divide that? Because in the point 0.0 the function f is not differentiable. So altogether we want to count. This is the S1, this is the S2, the arc length, the first arc length and the second arc length. The first arc length is just the integral from 0 until 1 of the 1 plus g1 prime y square dy, just by using this one. And the function is in the left side of y, or in the left side of 0. So we count it by using definite integral. We have this one, and that one, and that one. And if we make substitution from 4 plus 9y is equal to u, then we have something like this. The integral is very easy, and all together is equal to 1 over 27 times 13 square root of 13 minus 8. And by using the same way, we also can calculate the arc length of the g2y by using the same exactly the same y, but the function without minus. If the g1 is the minus here, and the G2 without minus. So altogether, the S2, that is the arctangle on the right side, is the G2, yeah, without minus. But because we take the square, then the result are similar, something like this. And we can count by using definite integral, and by using simple calculation, we have 1/27 times this number. And then we conclude that the arc length of these two, this and this, is equal to S1 plus F2. S1 plus F2, S1 plus S2, so altogether equal to this number. Now this is not good number, but anyway, it can be understood by using these two formulas.